welcoming the chief guest has become the part and parcel of our deep value-rooted culture. I invite Dr. John Milton, head of the department, to address the gathering.
Very good morning to all of you. Since we are running late, began schedule, I would like to be as brief as possible. And at the outset, I would like to thank God Almighty for us, for His wonderful blessings this morning. In a special way, I would like to welcome the chief guest of today's inauguration, Dr. Murugan, former Vice Chancellor of Loyola University. A world very well-renowned mycologist, and in a special way I would like to welcome our secretary and correspondent, Reverend Dr. Boniface Jayaraj, a wonderful human being and someone who has been inspiring both the staff and students of this great temple of learning. We would like to welcome you in a special way amongst all of us today. And I would like to welcome the convener of today's conference, Dr. Raja, the organizing secretaries, Dr. Felicia and Dr. Balachandran, and especially for having taken pains to make arrangements for this 2 days international conference. I could see many invitees from other institutions, Professor Pugaredi from the Madras University, Dr. Dhanraj, a very well-renowned entomologist, a former chief entomologist of Central Corporation, and he was a very inspiring person, and when I was a PhD student I was able to get a lot of inputs from him, a wonderful person. And we have scientists from and research students from entomology research institutes, and I could see a few teaching faculty members from other institutions of the Chennai city, and the student participants from other colleges. In a special way I would like to welcome all of you. And since we have a lot of things to do after the brief inauguration, once again I would like to extend a warm welcome to all the participants for having taken the initiative of taking part in this inauguration and other sessions of this international conference. Welcome all of you once again. Thank you.
Thank you, sir. Light manifests victory over darkness. Light symbolizes knowledge and wisdom of free will. It also marks the beginning of any auspicious moment. I now request the dignitaries on the dais to light the lamp.
To solemnize the event, I would like to invite our chief guest, Dr. Murugan, to light the first wick.
Followed by Reverend Dr. B. Jayaraj, Secretary, to light the second wick.
Followed by our HOD.
Followed by the conference convener, Dr. M. Raja, to light the fourth wick. And Master Elias Justin to light the fifth wick, along with Dr. Kate Racia Matthews.
It is time to honor our chief guest for their valuable presence among us. I kindly invite our HOD, Dr. John Milton, to felicitate our chief guest with a bouquet. I request Dr. M. Raja, conference convener, to represent a gift as a token of our gratitude.
I request Dr. K. Theresia Matthews to felicitate our Secretary Father. I invite Dr. Robert Selvam to felicitate our head of the department.
Reverend Father Secretary is a man of distinct vision and fountainhead of illuminating ideas, an ideal of knowledge, experience and inspiration to all of us. I request Reverend Dr. P. Jairaj to invoke us with his blessings for this conference.
The chief guest of today's inaugural session, Dr. Murugan, the former Vice Chancellor of the Loyola University, and the former Registrar of the Bharatiya University, and an eminent scientist. He is among the scientists. Just last week we felicitated one of our, two or three of our professors who were in the top 2% in the whole world as scientists, and Sir is among the top 1% in the scientists. So I am very happy that Sir is presiding and going to give an inaugural address. I knew him as the Vice Chancellor of the University, because at the time I was the principal of Loyola College, Loyola, which is under the Loyola University. So we used to go and meet him for any help for our college, and then he was always very, very, very generous to Loyola College, because he is an old student of our college, ERI, because he did his PhD in ERI under Dr. Inyasutu, who is also one of the top 1% scientists on the 1% of the world. So, he has been guided by an eminent scientist, and he himself is a very eminent scientist. And we invited him also for our graduation day to the Loyola College, Loyola, and he came there and delivered a wonderful speech to our students, graduation speech. It was very inspiring to local students, and it was very, very friendly with all of us. So I am very happy that he is here with us to give the inaugural address. Today when we went for a walk in the morning, I met him in the morning. So Father, he was saying, "But you are here?" Yes, I said, "I am here." He said, "Father, I have come here to my paper is the first paper to be presented, so I come here for this." At the time itself, I told Dr. Raja, the convener, you have admitted a very eminent person. This is what I told him at the morning itself. So, in that way, I am happy that he has come here to give the inaugural address, and his paper also will be presented. And of course, I am also happy that many other professors from all over because this is supposed to be an first international conference to be organized by Dr. Raja in collaboration with the Department of Advanced. So it's very, very happy that you are, some of them I think are online and they talk online. But here, from our own South India, North India, very eminent scientists are there. And the top we must try to understand there are ways how the insects and other aspects are have to be controlled, but not through chemical means, but through biological means, so that it is also to protect the environment. So environment is protection is very, very, very important these days. Both are important. We need to have a pest control, insect control. At the same time, we need to have a sustainable development. And also, we need also to develop they all each other. Diversity is also important. So preserving biodiversity and having a sustainable progress in the environment are both important. And today's conference, we are going to discuss all these things. So I'm extremely happy, and I wish that this conference will discuss all these things. At this moment, let me congratulate Dr. Raja for having organized this first international conference. I'd like to thank Dr. John Milton, who is head of the Department of Zoology, and other professors who have been collaborating with him in organizing this. Let us give them a big appreciation and thanks. And Professor Matthews is organizing secretaries, and Dr. Raja convener, and Dr. Milton is the chairman of this conference. So I'm happy that the very good organization has taken place. At the end of these 2 days, you will be enthused to preserve biodiversity and to create a sustainable development which protecting the environment. This I wish this conference all success. Thank you very much.
Thank you, Father, for your words of blessing. Strong lives are motivated by dynamic purposes. I now request the convener, Dr. M. Raja, to enlighten the gathering with the dynamics of the conference. Sir, please.
A very good morning, all of you. Knowledge is of no use unless you put it into the action, said Marcus Garvey. A wonderful morning to everyone present here. Gives me great pleasure to invite you today this international conference on recent technology for sustainable development of insect, microbes and earth. I believe that our gathering here today reflect the growing recognition of the importance of recent technology for sustainable development and our collective responsibility to address the environmental, social and economical changes facing our world. The international conference will provide a value-added opportunity for knowledge sharing among the professors, research scholars and students to learn technology in entomology and microbiology in association. This conference highlights about the sustainable development of insect, microbes and earth. Insect with every expedition association with the microbes during the life cycle. Insect create the biological terrestrial ecosystem. The cycles nutrient, the pollinate plant, disperse seed, maintain soil structure and fertility, control population of other organisms and provide a major food source of other taxa. The microbes contribute to the human body through digestion, produce vitamin K, promote the development of the immune system and detoxify harmful chemicals. And of course, Microbes are essential to making many food. Microbes are essential to making many food we enjoy, such as bread, cheese, and wine. Unfortunately, students often think the microorganism in negative terms. The negative attitude are supported by the public health and the media focus on microbe-caused disease as well as advertising for microbial destroying soap and cleaners. Although reducing disease transmission is important for individual and community health, the students also need to understand the beneficial contribution microbe and microbial community provide. The sustainable development is an idea that has gained significant traction over the past few decades. It is a development approach that meets the needs of the present without compromising the ability of future generation to meet their own needs. It is a concept that recognizes the interconnections of economic growth, social progress, and environmental protection, and it is approach that requires us to work together across borders, sectors, and discipline. The theme of the conference, Recent Technology for Sustainable Development of Insect, Microbes, and Health, basically encompasses of ideas in action. It undergoes a need to move beyond talking about the sustainable development to taking concrete action that can make a difference. It is only through collective action that we can achieve the sustainable development goals set out by the United Nations, which include eradicating poverty, reducing inequality, and protecting the planet. To achieve this goal, we must adopt a holistic approach that integrates economic, social, and environmental consideration into their decision-making process. We must promote sustainable consumption and production patterns, invest in renewable energy, and protect our national resources. We must also prioritize education, healthcare, social protection program to ensure that no one is left behind. This conference provides an excellent opportunity for us to exchange ideas, share the best practices, foraging partnership that can drive insect, microbes, and health forward. I encourage you all to actively participate in this session and engage in meaningful discussion that can contribute to the development of the innovative solution. In closing, I would like to emphasize the challenges of few phases are significant, but they are not insurmountable. Though the collective effort, we can build a more sustainable and equitable world for ourselves and the future generation. Let us seize the opportunity to work together towards a brighter future. Another goal is to promote scientific information, interchange between the researcher, developer, and to work together towards the bright future. The conference will be held in regular interval to make it an ideal platform for people to share views and experience. The CIMSER Department of Advanced Zoology and Biotechnology is organizing the international conference in order to articulate research talent to motivate the research aptitude. I ensure that this conference will include fascinating research ideas in the younger researcher brain. Thank you.
Thank you, sir, for enlightening us with the highlights of this conference. No event is ever a success without the guest. I call upon Dr. Anita Sebastian to introduce and invite our chief guest.
Good morning to all present here, respected dignitaries on the dais, guests, faculty members and students. I deem it my honor and privilege to introduce Professor Dr. K. Murugan. Professor Dr. K. Murugan completed his PhD from the Entomology Research Institute, Loyola College, Chennai, and has been conferred the Doctor of Science degree by the Bardiyar University, Coimbatore. He was also the former Vice Chancellor of Tiruvallur University. As an enthusiastic scholar, he had carried out his postdoctoral research in internationally reputed institutions such as the National Institute of Agrobiological Sciences, Japan, and Department of Zoology, Oxford University, to name a few. Professor Dr. K. Murugan is presently working as CSIR Emeritus Scientist, CSIR, Government of India, at the Department of Zoology, School of Life Sciences, Bharatiyar University, Coimbatore, and is also working as mentor professor at Department of Zoology, School of Life Sciences, Bharatiyar University, Coimbatore. Previously, he has held several prestigious positions in India and abroad. He has done cutting-edge research on the synergy among plant-borne compounds with microbial insecticides and arthropod predators for the successful control of insect pests of medical and agricultural importance. His significant contributions in metal nanoparticles with excellent mosquitocidal properties was a milestone study in his field. He is also currently researching the applications of stem cells for people who suffer from visual and orthodontic disorders. He has published over 460 peer-reviewed papers in reputed national and international journals besides 2 books. He has graduated around 5 postdoctoral and 55 doctoral scholars and several MPhil and postgraduate students. He has several prestigious national and international awards to his credit. He has been named among the world's top 2% scientists in the field of mycology and parasitology by the Stanford University ranking, consecutively for the past 3 years from 2020 to 2022. He has also been listed as one of India's top scientists in biology and biochemistry by research.com ranking in 2022. With these few words of introduction, dear participants, please join me in welcoming Professor Dr. K. Murugan to share with us his expertise on biological management of insects and host plant biodiversity. Thank you.
I invite our chief guest to kindly share a few words.
Very good morning to everybody. Really, I am very happy to be here as one of the participants for this international conference on International Conference on Recent Technology for Sustainable Development of Insects, Microbes and Health. Really, I am very happy, and I am doubly happy because I am a old student of this college. Because I studied in Sulaimadu from 6th to 11th here only in Gombaka. I studied in Pachipas College for my BSc, MSc Madras Krishnalai Tamira, MPhil in Endocrinology in PGIBMS Taramani, and PhD in ERI Loyola College. And really I am very happy, and I happen to see today our father Jayaraj sir in the morning, and later I have shared the podium with him. It really is a very great honor for me because I got his blessings, and wherever I go, I used to serve for our Loyola College institution. Okay, and first of all I used to thank Dr. Raja for inviting me for this conference, and our head of the department, Dr. John Milton, and my dear friend Dr. Pogalendi from University of Madras, and my dear old friend Dr. Dhanraj, public health entomologist, and Dr. Robert Selvan, Dr. Raja again, and Dr. So all the teaching staffs and non-teaching staffs, all the sisters and father, brothers in this institution, and really I am very happy. And after this formal inaugural session, I am going to talk on the butterfly conservation and biodiversity of host plants. as well as the control of mosquito vectors by nanotechnology, if time possible. And India is one among 10 mega biodiversity country, and then it is a world topmost hottest hotspot from Himalaya, Western Ghats, Eastern Ghats. And really, we are very happy, and we have a lot of biodiversity in terms of flora and fauna. And the conference, Dr. Raja has arranged this conference in a right time. Even though we have a lot of attention on biodiversity, still we should know various biodiversity in agriculture or medically in other part of ecosystem. So it is a very nice conference, I think, and moreover the zoology department is a quite oldest department. It started during 1948, and the great professors like my own Professor T. Anandakrishnan, and world-renowned entomologist, and my DSc mentor, Professor Dr. Father Ignacy Muthu, and Dr. Murthy sir, Pseudoscorpion, Dr. Raghunath Rao, Suckerfish, Dr. Selva Nayakam, and now Dr. John Milton. So the zoology, wherever I go, I used to talk about zoology is now very big subject, and also it is a parental subject for any other science, even medical science or agricultural science. It have bifurcated from zoology. So you zoology students has a lot of I think intellectual, and they are all very, I used to say all zoology people are very great people like that, because we have to love the subject, whatever the subject we have taken, so that it is a very, very important. So that I have taken my subject zoology and then entomology, and where I worked on grasshopper. Now I am dealing on biodiversity of butterflies and mosquito, so that I have succeeded in my life. And I have my own satisfaction. Similarly, I wish all later scientists or budding scientists of zoology, and you should study, you can go anywhere, you can work any subject all around the world. And I thank once again the organizer for inviting me for this conference. And really, this conference will bring out more laurels, and people will interact, discuss in various issues, not on zoology and allied subjects like botany, chemistry, nanotechnology, stem cell biology, and so on. So that once again I thank our father Jairaj sir and Madam Jessie, all other teaching, and my own budding scientist or zoologist. Thank you once again. Thank you very much.
Thank you, sir, for your valuable insights. I now invite our convener, Dr. M. Raja, to felicitate the guests from other institutes. I now invite Dr. Dhanraj, former Chief Vector Control Officer, Greater Chennai Corporation. Sir, please. Followed by Dr. Sivakumar, Principal Scientist, National Bureau of Agricultural Insect Research. And Dr. Pugalendri, Associate Professor, Madras University. Thank you, sir, and thank you, dear guests, for your valuable presence.
I request the dignitary on the dais to occupy the front seats. Let us now proceed to the keynote address of the event. Sustainability is no longer about doing less harm. It's about doing more good. I now invite Dr. Anita Sebastian, Assistant Professor, to introduce and invite our keynote speaker.
Esteemed dignitaries, faculty members, participants and students, once again it is my privilege and honor to introduce to you one of the eminent scientists, Dr. Sudhakar Muniyasamy, Principal Scientist, CSIR South Africa, joining us online to share his views and contributions on sustainable bioplastic and biocomposite for agriculture applications. Dr. Sudhakar Muniyasamy holds a PhD in Chemical Sciences from the University of Pisa, Italy. He is currently leading R&D on sustainable bio-based biodegradable plastics at the Chemicals Division of CSIR, South Africa. He is also a research associate at the Department of Chemistry, Nelson Mandela University, South Africa since 2013. Prior to this position, he was a postdoc researcher at the University of Guelph, Canada, and a project officer at the Department of Biotechnology, Indian Institute of Technology, Madras. His current research activity mainly focuses on development of sustainable biodegradable plastics from renewable resources and studying end-of-life options and verifying the environmental claims for bio-based products. He has authored and co-authored numerous peer-reviewed papers in the fields of bio-based polymers and biodegradation. He is an NRF-rated researcher and he holds various awards to his credit, like the Best Business Development for CSIR Chemicals South Africa, CSIR CEO Award to Project Synapse Bioplastics, Enviropedia Ecological Innovation Award, to name a few. He was also a recipient of the prestigious International Galileo Galilei Fellowship for top 3 young researchers in chemical science at the University of Pisa, Italy. With these few words of introduction, I now invite Dr. Sudhakar Muniyasamy to address the participants.
I Mukesh, can you start? Okay. Can you see my presentation? Okay. Good morning, everyone. Am I audible to everyone? Okay. Can you see now? Okay. Good morning, everyone. I'm Dr. Sudhakar Muniyasamy. I'm from CIMSER, Pika. I'm also my MPhil degree in Loyola, 2004. Advanced Scholar in Biotechnology. I'm an old student. Then I after that went to PhD Italy. Then I done a postdoc in Canada. Now I'm working as a principal scientist at CSR. So thanks for Loyola College for inviting me for this important international conference on recent technology for sustainable development of insects, microbes, and health. This was organized by the CIMSER, that technology. So my talk is going to be mainly on. Also, I want to thank Dr. Raja, especially he constantly he's been touching with me and he's taking all the progress what is happening in the various country and everything. So I am a special thank to the professor, father, and all my Teresa Matthew, John Milton, some of them Pushparati. Those are my senior. So I have a quick receipt Loyola College. Thank you so much. So I'll give a presentation mainly on what I am currently doing at CSIR, sustainable plastic and composite products for agricultural application. How this technology taking from the plant-based material, how can you use it for agricultural applications? So before I go to my presentation, let me explain what is CSIR. So it is similar like India CSIR. It's a government-owned institute. So we have head office in Pretoria, and also we have branches in different provinces like Etobo and everything. So we have around 2,500 employees. So among them, most of them is a PhD holders. Caring background, most of them. So basically, the employees, we have 62% Black South Africans and 60% female South Africans. And also every year we publish around 530 research publications. And also we generate new patents, 22 patents, 50 technology demonstrations. That means we develop a technology and we transfer to the industries. So that we also see, the whole CSR, it operates like 2,534 million rand, South African rand, that we operate every year. And also we, based on the technology we transfer,
we get a royalty to the CSR. So 5.4 million we every year get. And also we investing a lot of money for the human capital development. Some of the students from international or local students, they want to do internship. They did so, like they want to do master project or undergraduate project, or they want to do PhD, or they want to do postdoc. Everything we will also be give a funding. So we are operating. We are spending around 126 million rand for the human capital development. So the objective of the CSR is to we are the accelerator. Is one of the leading leading institute in the whole South Africa. So this we are main objective is we want to accelerate the socio-economic prosperity in South Africa, leading to its innovation. So we do the collaboration work, and we want to localize the technology and provide a knowledge-based solution for the sustainable development of industry and society. So we have a different kind of disciplines. We have advanced agriculture, food, and we have chemicals and belongs to chemical group. So basically what we exactly the chemicals that we extract valuable chemicals from the aquifers, materials, or we produce biopolymers from microbes, and also the valuable organic compound we produce from textile material. So we are trying to find out what's innovative there, and also next generation health related biotechnology, gene sequencing, microbiology. So those kind of work we do. And also we have a manufacturing, mainly on mining. As you know that South Africa is well known for mining. So we support mining, and also and the platinum manufacturing. And also we have defense security. Mainly we all the defense related work also we do that radar system. And also we have if your technology based something is established, also we have like a smart classes. We do the like techno-economy, whether the technology is viable to the globally or viable to the industry. Also we do the techno-economic, and also we do like life cycle assessment of really is viable, is going to benefit to the country or benefit to the industry or something. So also, if you want, anyone industry the like CSR technology, we brought it to we set up in various countries, various places. So we have something like a logistic approach. We have it, and also we have some of them. We develop a technology, something we want to create a new industry. So we will give assistance if someone coming, the investor or some industry comes to CSIR. We do like a training how to set up a business and how we can take a technology. Everything we do a training, and so specifically we want to create a new industry through the science that you learned. So that's the way we work on it. So my research group, we have a different research areas: nanostructural material, and also metal conversion, biomanufacturing, biochemical conversion, and pharmacology. We have. So we get also for leading this project, we get a funding from local government as well as the international government. We give a funding. So we also start from the basic research, and also we do the advanced research, and also we do fundamental research. And then we work with the big companies like PSF, DuPont, and we do the collaboration, and we make sure that we are filing the patent, and also we have a pilot scale facility, because when you do the research in the laboratory, you always operate with like a 1 gram or 2 grams, something like that. But in the case of pilot scaling, you need to have something 200 kg or 500 kg something. So we have a facility to make sure that what you are doing in the laboratory, it typically works in the industrial manner. So then we also collaborate with the big companies, and we transfer the technology, and we create jobs, and we create economy, and also create the social economic benefit. That's the way the whole value chain of the CSI is working. So my presentation, so my research group, what we are doing here. So my presentation contains how the plastics currently that we are using it, why it is important, what's the consumption, what's the What's the problem, the plastic pollution problem? How can we address through the bio-based material? So how can we develop a sustainable plastic and a composite agriculture food product? Like what's the opportunities that have and what's the challenges you have? When you're considering that you want to develop something like environmentally friendly materials for the environmental application, what are the opportunities and the challenges we need? And also to my studies, how to make a sustainable packaging, circular economy. How, because currently the plastic that are using it just one time using and it's just putting in, but it's not fit in the circular economy. But our research, how can we bring back? Because we know that if we take a plant, there's a cellulose, hemicellulose, lignin is natural material. So you can develop a product, and after end up like you put into the soil or whatever in compost, after something or in marine water, something like that, in the microbes it degrades and it fits very nicely the circular economy. It's called the circular economy. Okay. So my R&D mainly how to prepare the biopolymers, how to make a bio-based biodegradable products for various applications like your packaging and everything agriculture. So what's the key outcome of the research? What's the impact that my project is creating? So if you look at currently the petroleum-based plastic, the production of petroleum-based, currently we are sitting around 360 million tons every year we are producing. That is a fossil fuel. It won't degrade. It takes more than 200 years to degrade. So, so if you look at the whole, it's a petroleum base because the consumption is increasing because the plastic is lightweight and it can replace glasses and its transparency and low cost. So many advantages. The plastic has a lot of advantages. But if you look at some application, where are those plastics are going? Packaging, mainly the packaging, the agriculture, the multi-stream application, and all the everything. These are the plastic single-use application. Because if we go for construction, if we go using the plastic for the some of the durable application, there is not a problem. But when you're using the single use, you are get straw, single use, and that is the amount 50 to 55% they are mainly using it. So even agriculture, there is a huge amount of plastic films they are using for agriculture application. You know what's it? Once you in plantation, it protects the plant, maintain the sunlight, maintain feed the plant, give a proper humidity, and also it controls the weed controls. There's a lot of advantage. But the issue is after you do the post harvesting, after the harvesting gone, but you have to this one it won't degrade because it contaminates with the soil. You can't recycle. So it's creating microplastic, and that comes and is coming to the everything. And if you go to the supermarket, anything like your meat packaging or fruit packaging, vegetable and everything. So the among this picture, you can see the common packaging. Nowadays, recently the COVID situation came, and they wanted to have hygienic food, like either vegetables or meat and fruits and everything. So the packaging is a play role. So what is happening? We mainly consider the food, but if we don't care for the package, we just take it out and throw it to the environment. That is not degradable. It takes more than 200 years. So another one. Currently, we are sitting like 8 million tons plastic that we are dumping to the ocean. So also the data say like by 2050, there is going to be more plastic in the ocean rather than fish. It means we are going to eat plastic rather than fish. And this is globally there's a drive how to address this issue. The plastics have become, because I can see that in India also they are banning some of the shop use plastic. They are bringing like a yellow bag, some manja bag, and also I saw that in other provinces also they are banning single-use plastic. But imagine if you or any other paper bag or something, it won't give bad properties, you know, like straw is better, it won't mess with the water and everything. So we need to find out better solution rather than, because the paper straw, whatever that is bit expensive. Plastic maybe the 1 rupee or 3 rupee, but the paper, but the manjal price something like a 10 rand, 50 rand. It's a bit expensive, but there's opportunities that you can develop a bioplastic from the plant. Then you can replace it, you can bring the same property. The advantage is after you use it, if you put it to the landfill or soil or what, it's going to be completely biodegradable. That's the advantage. So that's the way. How it works is simple. It's a bioplastic you're taking from the plant. You know, the plant, it contains cellulose, hemicellulose, lignocellulose material. This is a composition. So from that you can extract and each molecule. Then you can add some of the fatty acid, the plasticizer, like the natural material, like everything like glycerol and some of them. Then you can develop any number of products you can make. You can make a carrier bag, you can make a cell phone cover, anything you can make it. Then you can make it. Then what happens after use? You don't want to use anymore. You want to dispose it. If you put it into the soil or something, it degrades. What is happening is the microorganism that present in the soil or present in the marine water or present in the fresh water, it takes the carbon sources. That's called biodegradation process. So it takes the carbon sources, it gives the final end product like a methane, new microbial biomass and water. In the case of anaerobic digestion process, it produces the methane gas. So this process works. So what's the advantage of using bioplastic? No hazardous into the raw material, because currently, remember, the plastic, it has a lot of hazardous material, bisphenol material, a lot of styrene, very toxic material. Here, you have natural material, you have starch, glucose material, so there's no, and also imagine currently the petrol price is going down. Because it's a fossil fuel, the petroleum source only the plastics are manufactured. But this one, it won't compete with the petrol. So, so it's something like a plant-based. So the plant it can grow every year. It can grow. So it's annually renewable material. So there's a possibility of reduce the greenhouse emission, and also it's giving opportunity. That is a circular economic in terms of recycling. That's advantage. And also social impact. Imagine, like in India, that we have a very good agriculture system. But what I noticed for the past 2 decades, something is going down, acclaim, because there is no proper value chain and the production is going down. So what is happening is you can use the agriculture waste, because you can get the agriculture waste, you can make a bioplastic. It means you can create a new industry. So the agriculture farmers can get benefit, because you are buying the waste from the agriculture people. So the people can benefit, and also you can go to create a new industry, cleaning industry, biorefinery industry, to make some biochemical industry or lignin byproducts or cellulose byproduct product, something. You can create industry. And also imagine when you're working on this environment, biorefinery environment, there's a less toxicity. It won't create, because it's a bio-based material. So there's ethically there's no kind of toxic here. You create like a green industry. So more jobs can create, and a new industry can create. There's a lot of opportunity. And also, so automatically what will happen? It's going to impact the country, because you are taking the waste material to make a new product. So when the production is coming, when the product, everything is going, the economy, the country economy, it will grow. So it will contribute to the rural development, and it will give a competition to the petroleum-based material. It will solve the environmental problem. That's the main. So what is bioplastic compared to petroleum-based? The bioplastic means the bio-based. The term, the bio-based, it means you are taking the carbon from the biomass. So anything from plant, anything from the forest resources, anything from the microorganisms. Microorganisms also can produce biopolymer, like a polyhydroxybutyrate. So anything, the carbon comes from the biomass sources is called bioplastic. So, so as I said, so on the left side you can see they ask the question, to make a bioplastic, what kind of raw material I can use? Any biomass, not necessarily be specific feedstock, any biomass you can take. You say either from organic waste or your food waste or lignous-related material, or it can be a forestry resource, any biomass, because the carbohydrate and the lignous-releasing material is the main ingredient, because all the biomass it has a composition. So it's not necessarily specific feedstock. No, you can use any kind of feedstock you can use to make a bioplastic. And another advantage, you can tell that, I developed the bioplastic from the plant, but I don't want to put it in the landfill or something. I want to recycle it, I want to reuse it. Can I reuse it? Yes. How the plastic currently they're recycling the waste, you can recycle it. You can also recycle it. But if even I want to make biogas, like a methane gas, or if I want to put it like a fertilizer, like a composting process, yes, you can do that. So that there is a lot of opportunity that you can develop organic recycling. If you don't want to go to mechanical recycling, like a plastic recycling, like a recycling, if you want to go to organic recycling, yes, you can do that. Like biogas you can produce, and also you can use composting, because after composting you can use as a fertilizer, then you can put it into the soil. Because it's a hormone enrichment, it can improve the soil quality. So when you talk about the plant plastic, where are we now? What's the market about this? And is it really penetrating this world? And is the potential? Yes, so currently the plastic market growth is only 3% is growing. Every year 3% is growing. But in the case of plant plastic, 30% of growth, annual growth is something is growing. So what I can simply say, by 2013, the dark blue is a plastic, the fossil fuel market. It was sitting like 455 billion US dollars. But that time, the plastic was very low market, less than 1%. It was sitting like a $3.7 billion. And then if you look at the around 2018, 2016. So what we noticed, there was a more production of plastic. It took like a 4% of market share. It took like 21 billion US dollars it comes. Currently, it also projected by 2030 is going to take 40% of the oil market. Means the plastic industry is growing globally. Currently we are around sitting like a $324 billion value of market, because mainly every industry, every year they want to go green product, and they want to have because it's coming from the waste material and it has a potential, and also a lot of plastic industry they are using it, they want to use. So that every industry they're going for plastic now. And if you look at the application wise, where this plastics mainly is going, so what we notice, around 60%, that is 1.2 million tons of the plastic mainly going for the packaging and agriculture application. That's the main, because they are not recycling, because the packaging is a rigid application and flexible application. The wrapping, food wrapping, and your carrier bag, and the straw, and the cutlery, container, those certain food containers, everything, takeaway containers, everything is a flexible item. And the like packaging items. Those are the market figures, and also agriculture. Your multi-film and your food packaging item, those are items they want to go back plastic. So the packed plastics is going to play a major role in the mainly for the single-use, short-and-use application. So how to develop packed plastic? So what we done in my research group, we have used a lot of agricultural waste and undervalued biomass, something like waste like no value, something like you remember sugarcane. After sugarcane extraction, there is a byproduct called bagar. Similarly, after corn, there is a byproduct called maize stalks. And after your paper industry, after the paper extraction, there is called paper. There is byproducts called lignin, and also the biofuel. There is called biodiesel industry. There is a byproduct called lignin, and glycerol, biodiesel industry. So these are the raw material. These are the agricultural waste, or you can call it as a undervalued biomass. There is no high value material. It's undervalued. It's very cheap and is abundantly available everywhere. So we can use this as a raw material to make a bioplastics. So what is happening? Is it's going to create a value for users, economic benefit, and it's going to replace the petroleum-based material, and it's going to reduce the greenhouse emission. That is the objective. So it can go to completely solve the greenhouse emission, and also it's going to address the plastic pollution, and also it's going to give value added. Means the material, you are taking the low value material and you are creating high value bio-based material. Yeah. Then see, this is a biorefinery, how it works. We take I'm just showing some example how the CSR is doing. We are taking like a pulp industry, biofuel crops like your how to say canola industry, some of the oil industries, byproduct. They can use this maize stalk and sugarcane industry byproducts. You can use that material and you can put it to the biorefinery process. The biorefinery process, you are extracting the value chemicals like your cellulose and hemicellulose, xylose, starch, and other carbohydrates and protein molecules. Those are the biorefinery process. You can extract, and what you can develop, what you can focus. My research mainly focused on the biomaterial. Currently, most of the global countries, what they are doing is using this biomass to make energy, bioenergy like electricity, biofuel. But what we are targeting, take this raw material, making more value, more than bioenergy, more than biofuel. You can treat like a biochemicals and a biomaterial. That's the focus we are doing it now. So this just I want to show the schematic diagram. How we are, for example, sugarcane bagar and maize stalk, then we are extracting the valuable chemicals like cellulose, starch, hemicellulose, lignin, or oil. Then you develop a plastic. Then you can, because when you make a plastic, it's this process called taking the monomer, and you have to do the polymerization reaction like oligomers and the specific catalyst, and you can make a plastic. And also, when you make a plastic, also imagine depending on the product. Like if you want a flexible application, if you want to have a rigid application, the property is very important. So you can play around how the mechanical properties you want, how the melting temperature you want, what's the molecular weight you want, how the hydrophobicity, you can play around. You can develop a product. Then also make sure that what you are developing material is also reusable and also it's recyclable if you don't want to put it into the landfill. Then at the same time, after end of life, if you put it to the compost or anaerobic digester or even landfill or soil, completely biodegradable. So that's the way we are working on it. Just I want to show some example. Taking the biomass, maize stalk, sugarcane crackers, then you ground it into and then you're extracting the cellulose. From the cellulose, you can do the another process called microbes cellulose, and also you can make the nanocrystalline cellulose or nanofiber. Then imagine the nano. I think you are already familiar with the nanomaterial. So the nanomaterial is something like a very small particle going to give a superior property. That is the advantage. So that's we are also working and taking the cellulose nanomaterial and we are developing a bioplastic material. So what we usually do, we extract a biopolymer and also we are producing like a bio-based like a polylactic acid, and also other like a PHP, polylactic natural material, and also polypropylene chitrinate. These are the natural biopolymer. So we put it to the extruder and we add a lot of plasticizer and everything. Imagine when you develop, when you develop a biodegradable product, we need certain specific property like a rheology property, melting properties. Those are the properties. So we do the extrusion processing, like industrial processing, and we get a granules. So the granules is is a formulation. So it's structure way, then you extracting the molecules like cellulose, chemistry. Then next process is you are making a fat plastic. You have to add certain plasticizer like sorbitol, glycerol, stearic acid and fatty acid, and you are adding. So it will connect the cross linking, and you will get some chemistry. Then you get a granules. That the fat plastic granule is an individual property. That's the formulation. So that is the formulation you can develop it, and you can check the property. The development formulation. What's the melting temperature? What's the potential of that property? Imagine composite material. This has a unique process and temperature, so own weight, so own something like this. This beginning, you can think of where your application you can go for. You can go for flexible application, or you can go just, or you can construction application. So these are the props you have to characterize it, and also make sure that how there is all the details along this details, all that you can. So just one the one. So this the cutlery, take a container, make something like a biodegradable. So what I done it, I used the microbes and cellulose and blended with polylactic acid, and also I blended with polypropylene succinate. Because imagine the PLA, polylactic acid, this also comes from the old cornstarch. They opening polymerization or another polymeric color, then you can develop a path. What is so it breaks. So you can, to modify it, you can do the blending. So bring the starch into this, and then you can balance the property. Like because if you're looking for career-based application, you should be the flexibility is very, very important. You should not break it. So you can add starch, and then you can make the plastic. That's the one I want to show that you biopolymer, you blend it with microbes and cellulose, then you can balance the property. So I designed the material that can use it for rigid application as well as flexible application. The bottom one to show the differential scanning calorimetry. Another one is thermochrometry. It will tell you the various material making them constant temperature and everything. That how to test material and how it behaves and then how can we use it. Just in the grams, from you can send it to any companies, plastic companies, injection moldings or any converter. Develop a number of products, rigid product. So what we developed is the CSR bioplastic technology. It has a very good mechanical property. That are the properties similar like a conventional plastic, like a polyethylene, polypropylene. It has a very good property. And imagine to use this bioplastic, we don't need any specific equipment. You can use the existing conventional machine like your extrusion processing or injection molding process. So no need to buy any machineries. Just take the grams and you can manage it in this normal machinery. And the advantage is it is 100% biodegradable in soil, compost, and in water. and the material is based from renewable resources. There is no plastic into this, and it can go. It is suitable for many applications. Flexible plates, agricultural plates like a mulch plate, nursery pot. So many options can be used here. So another one also. Material, like for example, your package the property, you can play around. Oxygen permeability, you can control the oxygen permeability, control water density. So something polypropyl, some of the concept. You know that when you're extracting the lithium, you know the what's the chemistry. It's an aromatic ring. So you know that it's a aromatic ring is a hydrophobicity. Then you can apply. Like a hydrophobic. If you're looking some application you want to have a you don't want oxygen, you want to stop the oxygen permeability because you want to, for example, in the banana, you want to keep it for a something like a 20 days or 25 days. You can play around. You can using the barrier properties. That also you can play. So that this is just to want to show how the biodiversity was happening. So what we developed the material within 2 months, it almost reaching 80%. So within 3 months, it's reaching 90% of biodiversity. So I just want to show some of the figures that what I developed it, how it's degrading. This is, when you talk about biodiversity, there's a two processes very important. It's not like your material is a microorganism eating and giving a end product. The first process is called primary degradation. So the long chain molecule, it has to break into smaller components. That's all you can see 0 days, after 70 days, after 30 days, smaller fragments happening. So these fragments, what is happening is a low molecule compound. So microorganism is going to consume this low molecule compound. So it's not like we have a big long chain molecules, it has to break the microorganism that secrete something like the intracellular or extracellular enzymes to break into smaller chains. That is happening, the first process. The second process, and assimilate is happening, that you can see. So just I want to show, these are the products I developed in my laboratory. The one is the carrier bag. That's the bottom one is the cutlery that you can use it. So you can see how it's biodegradable. I think that's film after 70 days completely disintegrating. So in the cutlery also, 45 days also started. So the technology already is a technology readiness level something like a 7. It means it is industry validated. It can go for completion. So we have done all the trade. And also I just to show how so also some mark E. The microbes is growing on the polymer surface after 140 become completely soluble. This kind of application it's going to solve plastic in the marine water because here this is not you won't treat it as a microplastic because this natural material is water soluble. But currently the petroleum based one due to sunlight is a small particle is going to be like it creates a nanomaterial like microplastic. But this one is completely water soluble, completely biodegradable. So another one, very important. How can I find out is a bioplastic? How can I find out this is a issue? You that's one is going to be same. You can't distinguish. Is a bioplastic or this is a petroleum. So there's internationally there's a process. If you are developing the material and you want to take it to the market, you have to send it for certification to make sure the material gives on the it's completely degraded. And you are testing. Once you have approved So when the microbial you should put a low on surface and treated consumer and that material is not a plastic material. This is a based plastic for it they can handle because currently if you don't have proper identification, it will create a very huge problem. You know, you can't if you put plastic together and this petroleum plastic together, if you want to go for recycling, it will affect the industry and it will create a huge problem because imagine this one is a different chemical composition, the petroleum based one is different chemical state. If you put together, you can't recycle. So therefore, the identification of plastic very, very important. So you got to carefully put the logo and get a certification. So currently, CIMSER in India they are doing it. So if you develop something, you can take it to CIMSER and they will do the verification and they do the certification. Then the Central Pollution Board they give a so can put that number in the product. So then you can take it to market. That is actually what to do. Yeah. So basically, because imagine they'll ask you develop the product and you testing it in different which environment is good. Where is degrading very faster. So I tested the material in different environment conditions like the compost, soil, fresh water, and marine water. What I noticed. If you put it in the compost, the plastic material, compost is degrading very, very faster. Within 3 to 6 months, it's completely degraded. But soil takes a little bit, little longer time, like within 12 months. Imagine because the compost it contains a lot of fungus, thermophilic bacteria and fungus. That's a playing role in actually. Like in a low temperature, like bacteria is playing, and also fresh water, so bacteria is playing, and some marine water diluted bacteria. So the plastic, is a great advantage if you want to trigger the degradation. If you want to quickly degrade, that also can play. And imagine that's also there is R&D required. So also I created a mechanism how the validation is happening. So if you have a chemical chain like a hetero chain backbone and there is hydrolysis process happening, the microorganisms secretes an extracellular enzyme like lactase and some of the enzyme, hydrolytic enzyme, then break into smaller pieces, the microorganisms eating the product and giving you a final product. If you have that carbon pattern like a rubber or lignin, polyvinyl alcohol like a that the process it won't taken by hydrolysis, but that you need an oxidative enzyme like a peroxidase kind of enzyme. Then it can break into white rot fungus. It can create a enzyme. So it can what is happening? It breaking into fragments. Then microorganism is eating the product. So that's the one we developed. These are some of the products are ready to develop. If you have time, you can in the Google just go and type my name or some of the link. I can share the presentation. Some of the achievement we done that we have a license with a lot of technology, a lot of flexible wherever the problematic plastic that you want to replace with the better plastic, bad plastic, we have done it. So this project, the potential impact is, it can imagine you are utilizing the waste material under waste, it will create a local containerization. You no need to import like from overseas or something. And there's you can create your own industry because it will create local value to the material. So there's you can use any number of agriculture biomass that you can create a cost-effective technology. And also it can create a investment to the agriculture farmer, as well as it can create jobs, as well as it can create an industry to the system. And also bringing this kind of concept, you can reduce the greenhouse emission, and also you can address the plastic pollution issues and create a cleaner environment. and you can leave it to the future people. Yeah. So I acknowledge my team, project team, and also the funding to this project, National Research Foundation, Department of Science and Innovation, and the Department of Science and Economy, and the CSIR, and the Environment Research Group, and also to this project. Industrial partner is very important because you doing in the laboratory and it doesn't align with the industry issue. So you need to always align with the industry and do that work. Yeah, thank you.
Thank you, sir, for your valuable insights. Express gratitude for the greatness of small things. At this event, to extend our sincere gratitude for your valuable present, I call upon the organizing secretary of the event, Dr. K. Tracia Matthews, Assistant Professor, to deliver the vote of thanks. Ma'am, please.
It gives me great pleasure to propose the vote of thanks. We thank the Lord Almighty for His grace and blessings. We thank the management of Loyola College and the Department of Advanced Zoology and Biotechnology for the encouragement and support. We thank Dr. Murugan, former Vice Chancellor, Tiruvallur University, former Registrar of Bharatiyar University, for being the chief guest of the conference. Thank you, sir, for accepting our invitation and for being with us. Thank you so much. We thank Reverend Father Dr. Boniface Jayaraj SJ, Secretary and Correspondent, Loyola College, Chennai, for gracing the occasion, a scientist by himself. We thank Father. Our thanks are due to Dr. Sudhakar Munyaswamy, Principal Scientist, CSIR, South Africa, in joining online on bioplastics, developing green material. Thank you so much. We thank Dr. M.C. John Milton, Professor and Head Department of Advanced Zoology and Biotechnology, for the welcoming, the gathering, and all his support. Thank you so much, sir. We thank Dr. M. Raja, the convener, for highlighting the dynamics of the international conference and its relevance. Thank you so much, sir. We thank Dr. D. Robert Selvam, Dr. M. Balachanda, our secretaries, for their support and help rendered all throughout. Thank you so much. We thank all our department faculty members. We thank Dr. V. Pushparani, Dr. Anita Sebastian, Dr. Maria Paikyam SJ, Dr. Jaren, Dr. Renilda Sophie, Dr. Mahesh Daniel, for the support and the encouragement given. We thank all our officials, deans, vice principals, faculty members for timely support. We thank all our invited guests, Dr. Dhanraj, BCRC, Dr. Shivakumar, Professor Pogirelli, Dr. Justin, Dr. Daniel Regan, all scientists, invited guests, research scholars, participants, student friends, for your active participation here. We thank Mr. Gino Vimalin and Ms. Rihanna Jennifer for being with us as MCs. We thank our choir for rendering melodious hymn. Thank you so much. We thank all our sponsors, well-wishers, media, press for the support. We thank all participants in a very special manner. We thank each and everyone. Thank you so much.
I request the gathering to kindly rise for the national anthem.
In
Once again, thank you all for being present for this inaugural function.